Alright, problem number 19. Again, I probably won't work it all the way through, but I can at least get you guys started. We have this function, f of x equals this mess, and we're asked, same thing, find everything about it. The first thing I would do is let's rewrite this guy so it looks like stuff we know how to deal with. Instead of square roots, change it to the 1/2 power. Right? And then just like we did on the last problem, got to find the derivative, got to find the second derivative. See, the derivative here, we will have to use the product rule. Got something times something. To figure out the derivative of that second something, we'll have to use the chain rule, but we'll deal with that when we get there. So the derivative of 4x is 4. Leave all this mess alone. 2x squared plus 4 raised up to the 1/2. And then to that you want to add, leave the 4x alone, take the derivative of this guy. Like I was saying, it's the chain rule. The outside function is x raised up to the 1/2. The inside function is 2x squared plus 4. So we got this times 1/2 2x squared plus 4 to the negative 1/2. 1/2 minus 1 there. But then you're not done. You still have to multiply by the derivative of the inside. Derivative of the inside here is 4x. And thankfully this time nothing to divide by because it's the product rule, not the quotient rule. So we got this big mess, and there's probably different ways to simplify it, but the way that I think is the easiest is having these fractional exponents is really annoying. But they're the same thing being raised up to an exponent, so maybe we can factor one out. Maybe we'll factor out 2x squared plus 4 to the 1/2 and see what that does to this side of the equation. So this is where the algebra gets a little bit tricky, which is why I'm here. Factor out 2x squared plus 4 to the 1/2 from both terms, from this term and this term. And what are we left with? See, on the left we're left with just a 4. On the right we got a 4x, another 4x, and a 1/2. 4 times 4 is 16, times 1/2 is 8. X squared. And then we got this thing. So we used to have 2x squared plus 4 to the negative 1/2, and then we got rid of 2x squared plus 4 to the 1/2. We factored that out. So it's kind of like negative 1/2 minus another 1/2. We're left with 2x squared plus 4 to the negative 1. Again, if this gives you trouble, which I could see it giving you trouble, it's a little bit tricky with the algebra, work backwards. If you don't believe me that this is the right answer, take this thing and distribute it back through. Use all your exponent rules. I think you'll get back up to here or something similar. But it's nice having the derivative as something times something because this will be a lot easier to solve. Let's see, what should I do? I think I did decreasing on the last one, so maybe I'll do increasing this time. And leave critical points and decreasing to you. So f of x is increasing if f prime of x is greater than 0. We just figured out f prime of x. So we want to know when is 2x squared plus 4 to the 1/2 times 4 plus 8x squared divided by 2x squared plus 4. Instead of raising it to the negative 1 power, I'll put it down on the bottom there. When is that greater than 0? Okay. The thing to realize here is that when you take a square root, you're always going to get a positive number. The square root of anything is positive. The square root, so this term over here is always positive, so we can divide both sides of our equation by this term over here, and it won't flip this sign around. We'll be left with 4 plus 8x squared divided by 2x squared plus 4. It's greater than 0. So this line is equivalent to this line, and we can solve this line right here. The one thing I guess we should figure out, make sure our function is defined everywhere before we just get rid of this thing. So really it's the fact that what's on the inside here is positive, so we always can take the square root. And then once you take the square root, that's always positive. So really, to be as precise as possible, I should have said all that stuff. But at any rate, it takes you down here. And solving from here, let's see, maybe we'll subtract 4 from both sides. 8x squared divided by 2x squared plus 4 has to be greater than negative 4. Multiply this over to here. 8x squared is greater than negative 4 times 2x squared plus 4. That last step deserves a little justification. We can only multiply both sides of this inequality by the bottom because this is always positive. Right? Something squared is always positive, times 2 still positive, add 4 still positive. Otherwise we couldn't have done it because when this is negative, we would have had to flip the sign around. So you can't just leave it as always greater than if this is sometimes positive, sometimes negative. Since it's always positive, this is legit. And so if we distribute through over here, negative 4 times 2x squared is negative 8x squared. Negative 4 times positive 4 is negative 16. Maybe bring everything back over to the right, add 8x squared to both sides. You get 16x squared plus 16 has to be greater than 0. And this is something we can solve. I mean, maybe we can just look at it here. I guess you got a couple options, but x squared is always positive, right? Multiply by 16, still positive. Add 16, still positive. So again, we're in the case where this is always true. So what were we trying to figure out? Increasing here? It's increasing when x everywhere, from negative infinity to infinity. So there's another problem. I'll leave the rest of this to you, but really there's not a whole lot when you see this answer. But I think with concave up, maybe it gets a little bit more interesting. To figure out concave up, we need to figure out the second derivative. All right, to take the second derivative, you can use any form of the first derivative you want, but this guy, I don't think that'll be easier because we'll have to use the product rule, and then inside the product rule there'll be a lot going on. So you should get the same answer no matter which form you use, but I think I'm inclined to use something more similar to this. Maybe we take this top line here. Maybe we need another color. Let's take this top line and let's see if we can rewrite it over here a little bit more simplified. We'll leave the left-hand side alone. So 4 times 2x squared plus 4 to the 1/2. And then to that we add, and we got the 4x times the 4x times the 1/2, which is the 8x squared. Sure. 8x squared times 2x squared plus 4 to the negative 1/2. So again, you can use any form you want, but I'm thinking this one might be the least bad, although I'm starting to think it's going to be bad no matter what. So okay, we got to take the derivative of all this stuff here. Yeah, okay, let's do it. The derivative here, we got a chain rule on the left here, right? Bring the 1/2 down. So you got 4 times 1/2 2x squared plus 4 raised up to the negative 1/2. Then you're not done, you still have to multiply by the derivative of the inside. The derivative of 2x squared plus 4 is 4x. And to that we need to add, that just took care of the left here, the right-hand side. Right-hand side, we got a product rule, right? We got something times something. Okay. The derivative of 8x squared is 16x. Multiply that by 2x squared plus 4 to the negative 1/2. And to that we want to add, leave the 8x squared alone, and multiply that by the derivative of this guy, which is negative 1/2. So yeah, negative 1/2 times 2x squared plus 4. And then subtract 1 from your exponent, that gets you to the negative 3/2. And then we're still not done, the derivative of the inside is 4x. So this disgusting mess is our second derivative. But hopefully we can make it a little bit better. In fact, we definitely can. What we're going to do is use a strategy similar to what we did in the first part and realize that we got 2x squared plus 4 to the negative 1/2 here, here, and here. So, well, to the negative 3/2 here, but we have that same term in all three of our terms, so we'll factor it out. let's take out let's just take out 2x squared plus 4 to the negative 1/2. You have some freedom on what you do here, but I think this will make life easiest for you. So if you pull that out of all three terms, what you're left with in this guy, we took care of all that. So we got 4 times 1/2 times 4x, which is 8x. Over here, we took care of all this, so we're just left with 16x. And then this one, unfortunately, won't be as nice, but let's see what we got here. We got 8x squared times 4x times negative 1/2. Hard to see the negative sign. 8 times 4 is 32, times 1/2 is 16. So we got a negative, plus negative. Negative 16x cubed times 2x squared plus 4 to the negative 1. Negative 1 because we took out negative 1/2 from negative 3/2. So what we're left with is negative 2/2, which is just negative 1. So this is really ugly in here, but I can rewrite it. Maybe you see where we're going here. 8x plus 16x is 24x, plus a negative is really stupid looking, so we'll just make that minus 16x cubed times 2x squared. Actually, maybe 16x cubed divided by 2x squared plus 4. So this right here is our second derivative. I think this will be a lot easier to work with. Let's see, I'll just do one of them. Doesn't really matter what I do. Maybe I'll choose concave down this time. So f of x is concave down. This is getting really messy. When the second derivative is less than 0. So we got 2x squared plus 4 to the negative 1/2 times 24x minus 16x cubed divided by 2x squared plus 4. And we want to know when that is less than 0. Looks really difficult. Turns out that we can get rid of this term again because this term is always positive. Might be hard for you to believe it right now, but we can think about this is 1 divided by the square root of 2x squared plus 4. Right, and the inside here is always positive, so this thing is always defined. And then when you take the square root of a positive number, you get a positive number. When you do 1 divided by a positive number, you're still a positive number. So because this thing is always positive, we can divide it from both sides of the equation and make it cancel out. So what do I do with this? Maybe I'll just leave it. This part equals this. So therefore what we got is 24x minus 16x cubed divided by 2x squared plus 4 has got to be less than 0. To solve this mess, add all this over to the other side. You got 24x has to be less than 16x cubed divided by 2x squared plus 4. Multiply this over to this side. Gives us 48x cubed plus 4 times 24 is 96x. That's got to be less than 16x cubed. So what I did is I took 2x squared plus 4 and multiplied it over to this side, and then I distributed it through. Maybe I should have done that in 2 steps. But finally, if you get to this step, we can combine our like terms, so subtract 16x cubed from both sides and get 32x cubed plus 96x has got to be less than 0. And you have a little freedom on how you do this. I guess maybe let's factor out 32x, and what we'll be left with on this side is x squared, and on this side is 3. So the question is, when is this times this less than 0? Well, this thing in the parentheses is always positive, right? X squared is always at least 0, and then add 3, you're definitely positive. So this is always positive. You can divide both sides of the equation by it. It won't change anything. So really, this is the same as saying 32x is less than 0. Divide by 32, you get x is less than 0. which if you want an interval notation is that. So what we just figured out is that f of x is concave down when x is less than 0. And from that I'll let you figure out the rest of the stuff, and we will finally be done with that mess of a problem.